Hey everybody, it's Miss A. I'm happy to see you guys back, and I'm also happy to announce that this is going to be our last formal instruction video. So we're going to be connecting in different ways for the remainder of the school year. You still will be receiving video messages from me, but sadly to say, this is technically our last formal instruction together. So let's make it a good one. Let's end the year on a high note. Let's just jump right into it. Let's get started. All right, so our goal for this video is that we are going to solve exponential equations. We're going to start off with simple ones, and then we're going to get a little bit more complex. These are definitely big questions on exams like the SAT and whatnot, so you'll be happy to be going through these at the end of the year, so hopefully they stay fresh in your minds as soon as that SAT test opens up. Over the course of the week, I suggest that you split this into two parts. I'm going to come back to this when we're done with each of the parts that we have, but we've only got two parts this week. So here is part one. Now, part one is the problems that are a little bit more simple. Sorry, my pages are a little stuck together here. Are the problems that are a little bit more simple. The numbers are a little bit smaller, but if you need to, pause this video right now, grab a calculator. It will definitely be helpful, especially in the second part. So grab a calculator if you need to. All right, so let's get started. These questions are all only going to ask you to either solve or say solve for x or whatever variable that they're using if they're going to be really specific, but essentially they're just asking you to solve. You need to be able to identify the situation, what's going on, and then you go from there for your solving. So the situation that I have are two exponential expressions that are now set equal to each other. So this is an exponential equation. And I need to solve for these x's, but what's different this time is these x's are actually in the exponent. So what we're going to be doing is we're going to be identifying situations where maybe our bases are not identical, but we're going to make them identical. So you have to think about, is there another way that I can write 16? Is there another way that I can write 4 and make these numbers the same? And some of you might be thinking like, well, okay, well, 16 is actually a perfect square. 4 squared gives me 16, and then my bases would be identical. And if you were thinking along those lines, you are correct. So again, our goal is that we have to make our bases the same. So I'm just going to put that over to the side. Let me scooch down a little bit. I'm going to write make bases same. Okay, so once we make the bases the same, we can start moving forward in this process. So another way to write 16 would be 4 squared. Now I'm keeping the expression identical. It still has a power of x because I don't want to change this as far as its value. I just want to change the way it looks. 4 squared still gives me 16, so these two expressions are technically equivalent to each other. And I'm just going to bring down this side because it already had a base of 4. And now I have an equation that makes a little bit more sense, because if what I've written on the left-hand side is supposed to be equal to what I have on the right-hand side, they're looking a little bit more equal just in the fact that I have like bases. Now comes your rules of exponents. You might see right here that you've got a power to a power. Power to a power, what do? We multiply. So step 2 is going to be to clean up your exponents. Now, sometimes it's going to be pretty simple like this one. Other times it's going to be a little bit more complicated. You might already notice that from looking at the second problem, but really no big deal. 2 times x is going to give me 2x. So I'm just going to rewrite this as 4 to the 2x is equal to 4 to the 3x minus 1. Now, why did I do this? I set these two expressions equal to each other with the same base because if the bases are equal to each other, that means that my exponents must be equal to each other. And that is going to be a much simpler problem to solve, because if these guys are the same, then equal, then these guys must be equal. So I can actually just set my exponents equal to each other and solve to find out what that value of x is. Because think about it. If this was 4 to the second power, this one would also have to be 4 to the second power. If this one was 4 to the third power, then this one would also have to be 4 to the third power. So we need to find what number is making them identical. So step 3 is going to be to set your exponents equal and solve. All right, so 2x is equal to 3x minus 1. What I'm going to do is I'm going to subtract the 2x over. I like to keep my x's positive, so I've got 0 is equal to x minus 1. I'm going to add the 1 over to the other side because I want to get that x by itself, so x is equal to positive 1. Now, if you're unsure of this process and you're like, all right, I don't really know, Miss A, you can always double check yourself. Whenever we solve for anything in math, what do you usually do to check your work? You plug it in, right? So let's plug it in. Up here, I would have 16 to the first power because I would just plug in that 1 for my x. I'm going to write check up here. Okay, and over here, I would end up having 3 times 1, which is just going to give me a 3, minus 1, and 3 minus 1 is going to give me 2. So I would have 4 squared, once I clean that up, is 16 equal to 4 squared? Yes, it is. So you guys did this correctly. All right, so you can always double check yourself by plugging it in. Delta Math is only going to ask you for what that value of x is, and you're just simply going to type it into that box. All right, so step 1 is we're going to make these bases the same. So because if our bases are equal, our exponents must be equal too. Once we do that, we can clean up our exponents. So any little arithmetic that needs to be taken care of, you take care of it. Step 3, set your exponents equal and go ahead and solve. So let's try that again with example number 2. All right, for example number 2, I'm looking at these two bases. They're not the same. I'm thinking of numbers that I can turn them into. I know that 3 can't get any smaller, so let's see if we can make 27 smaller. And if you guys are remembering from just working with exponents in general, 3 to the third gives me 27. So I'm going to rewrite 27 as 3 to the third. And again, I'm going to keep the rest of this exponent because I'm not trying to change the problem. I'm just trying to change the way that I look, okay? So I've got 3 to the third still giving me a 27, all still raised to the 2x minus 4. So we've completed step 1. Step 2 is to clean up your exponents. Again, power to a power means multiply, but look at what I've got to multiply here. If you guys need to, put parentheses around this expression, because when you multiply, you will have to distribute 3 times 2x and 3 times negative 4. So this is going to be 3 to the, 3 times 2x is 6x. 3 times negative 4 is negative 12. And I'm going to keep everything that's on the left, 3 to the 2x plus 4. So now that my bases are equal, that means my exponents must be equal too. So I'm going to set them equal to each other and start solving. So 2x plus 4 is equal to 6x minus 12. And we're going to go ahead and solve. So I'm going to subtract over my 2x. So I've got 4 is equal to 4x minus 12. I'm going to add over my 12, so I'm going to get 16 is equal to 4x. To get that x by itself, I need to divide both sides by 4, so I'm going to get x is equal to 4. Again, you can always double check your work by plugging it in. Over here, we're going to have 2 times 4 is going to give me 8. 8 plus 4 is going to give me 12, so I have 3 to the 12th on this side. On this side, I've got 2 times 4 is going to give me 8. 8 minus 4 is going to give me 4. So I've got 27 to the 4th power. And if you put 3 to the 12th in your calculator and 27 to the 4th in your calculator, you will have the same answer. So you guys are good to go. All right, let's take a look at problem number 3. So again, I know 2 can't get any smaller, so I'm really going to focus on this 8. And if I want to make these guys identical, is 2 to some power going to give me 8? Yes, 2 to the third. So if I rewrite 8 as 2 to the third, and again keep my exponent of 2x plus 1, then I can go ahead and move forward with this problem. I have equal bases, so now I just need to clean up my exponents. Remember, when you have an expression, you need to distribute to everybody. So this is going to become 2 to the 3 times 2x is going to give me 6x. 3 times 1 is going to give me 3. The right side is staying the same. All right. Then we're going to set our exponents equal to each other. So I've got 6x plus 3 is equal to 2x minus 5. I'm going to subtract 2x and get 4x plus 3 is equal to negative 5. I'm going to subtract 3 over to get 4x is equal to negative 8, and then divide both sides by 4 and get x is equal to negative 2. Now, some of you might be saying like, oh my gosh, a negative number, there's no way. Yes way, guys, it can totally happen. All right, plug it in and double check your work. Negative exponents are allowed. Remember, it just creates a fraction for us, right? Because we have to move into the denominator since these guys right now are currently in the numerator. All right, I got 2 more, only because the numbers are a little bit bigger. Now remember, in different situations, sometimes maybe you only have to change one of the bases, sometimes you have to change both of the bases. Keep an open mind to all of this. Now, some of you might be also looking at these numbers and thinking like, oh my gosh, these numbers are pretty big. But remember, try to just work with one that you're unsure of. Like 16 can be broken down, right? 16 is a perfect square, 4 squared, but let's see if raising 16 to a certain power is 256. 16 to the first power is 16. 16 squared happens to be 256. So no big deal. I made this base look like this one by turning it into a 16. So what I have here on the left is going to stay the same. On the right-hand side, I'm going to turn 256 into 16 squared. It's still going to be raised to the x minus 1 power. I'm going to clean up my exponent by distributing that 2. So again, left-hand side is going to stay the same, and I'm going to have 16 to the 2x minus 2 after I distribute that 2. Now that my bases are equal and I cleaned up my exponents, if my bases are equal, that means my exponents are equal, so let's go ahead and solve. X plus 1 is equal to 2x minus 2. I'm going to subtract over my x, so I get 1 is equal to x minus 2. I'm going to add over my 2 and get x is equal to 3. Again, if you're ever unsure of yourself, you can always go back and plug in. So I'm going to take one more example of larger numbers. Again, some of you might see 36 and automatically think 6 squared. So that could possibly be an option as a base of 6. But again, let's just try and make this guy look like a 36 first before we start to go through those other avenues. So 36 to the first power is 36. 36 to the second power is 1,296. So no big deal. I can keep the 36s. So the left-hand side is going to stay the same. The right-hand side, I'm going to turn 1,296 into 36 squared. I'm going to still raise that to the 3x minus 3. I'm going to clean up my exponents over here, power to a power. I'm going to multiply, but make sure we distribute. Left-hand side, again, still staying the same. So I'm going to have on the right-hand side 36 to the 6x minus 6. And then now that my bases are equal and my exponents have been cleaned up, I'm going to set my exponents equal to each other. And I'm going to go ahead and solve. I'm going to subtract over my x and get negative 1 is equal to 5x minus 6. I'm going to add over my 6, and I'm going to get 5 is equal to 5x. I'm going to divide both sides by 5 and get x is equal to 1. Okay. And again, plugging that in, everything should be the same. Since this one's quick, let's take a look at it. 1 minus 1 is 0. Anything to the 0 power is 1. 3 times 1 is 3. 3 minus 3 is 0. Anything to the 0 power is 1. It works, guys, okay, even when it gets a little crazy. So stay confident. Use your calculator if you need to double check any of your arithmetic. All right, well, this concludes part 1 of our video. So if you guys are ready to, go ahead and jump on some Delta Math. Take your time doing it. Split it up in a couple of days if you need to, but you can click on Exponential Equations, Common Base Level 1, all right? Okay, part 2. All right, with part 2, you guys are going to see that obviously things are getting much more complicated here. Again, nothing to panic over because we are going to try and keep this as simple as possible. It's the same process. It's just that if you guys happen to see a fraction, remember, if we want to get rid of this fraction, I could just write this as 16,384 to the negative first power, right? When I want to bring it back up here, because if he doesn't want to be in the numerator, then if I'm going to write him up there, I need to put that negative exponent to let everybody know that. So instead, what I'm going to do is when I find my common base, that's when I'm going to write it with a negative exponent. So just keep that in the back of your mind, okay? Fractions equal negative exponents. And it all still works out, okay? Fraction equals a negative exponent. So if you guys were thinking that, oh my gosh, this is some like crazy large number, and then we've also got this base of 64, so let's try making him look like a 64. You might take out your calculator and say, all right, well, 64 squared, I'm just going to write this to the side so you can look at some numbers, gives me 4,096, which isn't enough, right? So if you do 64 to the third power, you're going to get 26,200, 262,000, my bad, 144. So that's obviously way too big here. So a base of 64 is not going to work. So let's try again. Let's think of smaller bases. Some of you might be looking at 64 and saying, oh, that's a perfect square, 8 squared, right? So let's take a look. If 8 squared is equal to 64, that would solve, changing the base on this side, but that would mean 8 to some power needs to be equal to 1. Oh my goodness, I can't say this number today. 16,384. So if that's the case, let's do a little bit more investigating. Now I'm going to jump up a little bit. I know that 8 to the third is not going to give me a big enough number. So I'm going to try 8 to the fourth because I know that's going to get a bigger faster. And that's going to give me 4,096. So not enough. So let's try 8 to the fifth power and see what happens. If I do that, I get 32,768. So too big. Okay, so even though I can change this guy to a base of 8, I can't change this guy to a base of 8. So base of 8 is not going to work either. The reason I'm showing you guys this process is because I want you to kind of strengthen your math reasoning skills and your basic math facts skills as well when it comes to exponents, and to show you guys it's not that hard. Trust me, just keep going with the process, try new things, don't give up. So what's another number that we could use as a base? Well, I'm thinking about 64. Yes, it was a perfect square. 8 didn't work though, but I know 4 to the third power gives me 64. So let's try turning him into a 4. So I'm going to jump up a bit because I know that if I raise 4 to the fourth power, 4 to the fifth power, it's still going to give me a smaller number. So I'm going to try 4 to the sixth power. And 4 to the sixth power is going to give me 4,096. All right, so still not quite enough. Let's try 4 to the seventh power. 4 to the seventh power gives me, oh my gosh, 16,384. So it works. I can turn both of these bases into a 4 and I can solve this problem. So let's get to it. Remember, this guy was in the denominator. I have to move him up. I got to get rid of the fact that there's a fraction here. That's no good, right? I don't want to deal with that, but that means I have to make him a negative 7. So I'm going to rewrite this as 4 to the negative 7, right? Because that would indicate I would be in the denominator, all raised to the negative 4x plus 12. On this side, I'm going to change my 64 to a 4 to the third power, all raised to the 4x plus 13. And I'm just going to carry out all the steps that I was doing before. We need to distribute this negative 7. So that's going to give me 4 to the 28x minus 84. Watch your signs there. That was a negative, right? Equals, I'm going to distribute this 3 on this side. So I'm going to get 4 to the 12x plus 39. And now that I have equal bases and I've cleaned up my exponents, that means my exponents are equal. So let's go ahead and set them equal. So 28x minus 84 is equal to 12x plus 39. I am going to subtract my 12x over here. So I'm going to get 16x minus 84 is equal to 39. I'm going to add over my 84 and get 16x is equal to 123. I'm going to divide both sides by 16, and unfortunately that does not go in evenly. But guess what, guys? Stop freaking out when you get a fraction. If you put all this into the calculator, you will get a giant number. You do have to be careful. Use your parentheses, use your fraction buttons if you have them on your calculators. It does come out to be a crazy like a number to the point where your calculator is going to put it in scientific notation. Putting this fraction in for these two values will give you 1.048, and it keeps repeating times 10 to the 79th power. So it's really big, but it does work. It is true. So trust yourselves, be confident. Just because you got a fraction doesn't mean you did it wrong. All right. But this last one, I want to show you a little bit simpler. You know, not all of these are as hard. As you can see, these guys are very close to being the same, but just not quite. This guy's written as a fraction. Remember, fractions just mean that they came from having a negative exponent. You know, they were cleaned up. So if I write 243 to the negative first power, it brings this guy up here, which is where he doesn't want to be, but I get rid of the fraction, right? And then the right side is going to stay the same. I'm just going to distribute that -1 to everybody over here. So I'm going to get 243 to the -2x plus 14 equals 243 to the -x plus 8. Since my bases are equal, that means my exponents are equal. So -2x plus 14 is equal to -x plus 8. To try and keep my x's positive, I'm going to add the 2x over, so I get 14 is equal to x plus 8. I'm going to subtract the 8 over here. I'm going to get x is equal to 6. And again, if you guys plug that in, you will see that it does work. So be careful. Part 2 definitely has larger numbers, but it's not impossible, especially with the help of a calculator. All right. So part 2, you guys can go ahead and start that on Wednesday. Break this assignment up. Don't stress yourself out. I know everything's coming to a close, but as the school year is winding down, of course. So, you know, go into Delta Math, do exponential equations, common base level 2 if you're good to go. Try the quizzes that I post on Google Classroom as well, guys, for a little bit of enrichment, especially if anyone plans on taking the SATs, hopefully in the near future. But otherwise, guys, I have good news. This is mission accomplished as far as major assignments go. There will be smaller ones posted for the remainder of the 2 weeks that we have left in school. So keep up the good work. You're really getting there. This is the home stretch. You're almost done. I'm so proud of you guys. And honestly, I can't wait to see you. I'm hoping that we're going to get some good news and be able to start our fall sports on time and have a great season. So for those of you who I would probably run into, you know, in August for preseason, I hope that I do get to run into you on the field outside. Please make sure that you say hi to me, flag me down. But if not, if we've got to wait until September to see each other again, I can't wait to see you guys in person then anyway. So be well, guys. And again, I will talk to you soon. No more major assignments for now, but you will have little ones along the way to finish up. Bye, guys.